Okay, for example 5, again, one of the two criteria is either log equals log, same base, or log equals number. All right, and it has to be log of something base b is equal to a number. It has to be exactly like that. I can't have log plus log, log minus log, 7 times log. It's got to be log all by itself equals some number all by itself. That's where I need to be. So when I get things being added, subtracted, or a number being multiplied by a logarithm, I have to use our properties of logarithms from back last Friday that we dealt with by pushing things into a single logarithmic expression. That's what we got here. So if you recall from last week, if I have log 1 plus log 2, if I'm adding two logarithms together, I'm going to multiply the arguments of those logs to make a single logarithmic expression. So I'm going to get log base 2, and I'm going to multiply x times x minus 2. Again, my whole goal here is to get single log expression equal to a number, because I happen to have a number on the other side. If I had a logarithmic expression on the other side, my whole goal would be logarithmic expression all by itself equals logarithmic expression all by itself. Again, it really doesn't matter which one of the two I get, I can work with it, but I need single log expressions, that's the requirement. So, at this point, if you have log equals a number, then we just transform to an exponential form. It's going to be 2 to the third power equals the argument. We change out of logarithmic form into exponential form. The base of the logarithm raised to the power of the logarithm equals is equal to the argument. Once again, I have a quadratic structure here. I'm going to see this is 2 cubed, which equals 8, right? So that's 8. If I move 8 to the other side, because I have quadratic, I want to equal 0, I'm going to get 0 equals x squared minus 2x minus 8. Once again, the quadratic structure has a 1 in front of the x squared. So I'm simply looking for a number, two numbers that multiply to make negative 8 that also add to make negative 2. Those answers are negative 4 and positive 2. If I test it out, negative 4 times 2 does make negative 8. Negative 4 plus 2 does make negative 2. So negative 4 and positive 2 are the magic numbers that factor. So x minus 4 times x plus 2 equals 0. And it says equals 0 on this side. I can just easily put it on that side. Most of us like the x's on the left, numbers on the right. So it doesn't matter where the equals 0 goes in your equation. So I've got two factors. Either factor 1 equals 0 or factor 2 equals 0. So if I get my x's for each of these, for the first one, if I move the 4 to the other side, it's negative 4 moves across, becomes positive 4. 0 plus 4 is 4. The second one, if I take the positive 2 across, becomes negative 2. 0 minus 2 is negative 2. So again, I'm getting two answers. I have to check the validity of those answers on the original problem, back up here. Okay, so when we're testing, we do make modifications on this problem here, right? But I want to test up here. That's where I need to test it. So what I'm checking is the arguments here. I need to make sure that this argument and this argument are both positive with the answers we have. If they are, fine. If not, we have to throw it out. So if I test 4, 4 is positive. 4 minus 2 is 2, which is positive, so 4 is a good answer. If I test negative 2 is negative. Right off the bat, it's illegal. Negative 2 minus 2 is also negative 4. Happens to make them both negative. If we had tried right here, negative 2 squared is positive 4. Minus 2 and minus 2 is positive 4. 4 plus 4 is 8, right? So we do get a positive number there, but the original problem is we're going to have to verify. That's what our problem was to begin with. So if the problem started here, both those answers would have been fine, but instead it started here, so we have to verify the positivity of arguments here. The negative 2 is not. So the only correct answer to this is x equals 4. More often than not, when you get multiple answers, several, like if you get two answers, more often than not, one works, the other doesn't work. More often than not. Occasionally they both work. Sometimes neither one of them works. Very seldom does that happen, but usually one works, one doesn't work. That's the one that happens most of the time. So if that's happening pretty frequently, you're probably in good shape. If you're getting both of them working every single time, that's weird. Probably messed up. If you're getting both of them don't work every single time, then that's also weird. So again, expect them, one works, one doesn't work most of the time.